Alright, today we are combining like terms. I actually don't like this word anymore. I want to do. Let's go back to this one. I can combine like terms. We're going to be doing all this green stuff, so we got a lot to go through today. So, first we've got our simplifying expressions. We can simplify algebraic expressions by combining like terms. So now that we know what like terms are and how to find them, we are going to be combining them together. So when we're combining them, we want to be careful to combine the terms to check the sign that is in front of them. And remember, by sign, that means it is positive or negative. So when we're adding them together, we have to make sure we're paying attention to what's positive and negative, because when we're adding positives and negatives together, we're actually subtracting because they're different. Or if they're the same sign, we add them together and keep the sign the same. So we still have to remember all of our addition and subtraction, multiplying and dividing rules for positive and negatives that we've learned earlier in the year. So next we've got all this pizza and ice cream and soda. So the Robinson family ordered snacks at the state fair. They bought the following drinks, which we're going to call D, pizza, which we're going to call P, and ice cream cones, which are C. We're going to write an expression to represent their purchases, which are all this up here. So the first thing we have are drinks. So let's count how many drinks we have. I've got 1, 2, 3 drinks. So drinks are represented by the letter D. So I'm going to put, I guess actually, I'm getting a little ahead of myself. So first, let's just go in the order. So left to right, we've got a pizza, which is P. We've got another pizza, which is P. We've got a drink. We've got a drink. Then we've got an ice cream cone, which is C. Then a pizza. That kind of looks like an E. A C. And then we've got another ice cream cone. Then 2 more pizzas. And then one last drink. So this is a lot. So we're simplifying it by combining the like terms. So all my P's are like each other. All the pizza is like pizza. All the soda, all the drinks, all the letters D are like terms. And all the cones, the C, are like terms. So we're going to combine those together. So if I look at the P's, I have 1 plus 1 plus 1 plus 1 plus 1. So this is 1, 2, 3, 4, 5, which I can also see in my pizza is 1, 2, 3, 4, 5 pieces of pizza. So I have 5 P. Then I've got my drinks. I've got 1, 2, 3 drinks, which means in my expression here I should have 1 plus 1 plus 1. So I have 3 total. 1 plus 1 plus 1 is 3 D. And then my cones, I've got 1 and then 2, which is also the same in my expression. I have 1C and then 2C. So now this expression that we've simplified is way shorter, way easier to understand what's happening. Like we can look at this right away. We have 5 pizzas, 3 drinks, 2 ice cream cones. When we have it like this, it takes us a lot longer to figure out what's going on because not everything grouped together. They're all just spread out all crazy. So to explain how this example can relate to an algebraic expression, which is again our like terms added and or terms being added or subtracted together with no equation, our answer for this one is that in an algebraic expression, each term can only be combined with another like term, like x's with other x's, which is like how pizza can only be combined with pizza. So here, we can't combine pizza and ice cream together because that would be gross. We don't want to put our pizza in our soda because that would be gross. We only want to put pizza with other pizza, drinks with other drinks, and ice cream with other ice cream. We want to keep the same things together. So whenever we have different variables, different letters, we want to remember we can't put those letters together unless they're the same letter with the same exponent. So just like we don't want to combine different foods together because they would taste gross, we don't want to combine different letters together because that's not the way that it works. We want to keep the letters separate. So now let's look at a couple problems. We're going to color code or use shapes. So in this one, we're going to color code. This one we'll do shapes. The first one they already did. They did the shapes. So we put a square around B, square around B, circle around our constant, circle around our constant. Then we put our squares together and our circles together to get our answer. So let's do colors first. So I'll make my J's green. So 4.2J is green, and then I've got my 6.7J, and I'm keeping the plus with it. Remember, whatever the sign is in front of it, we're keeping it with it. And then I have a negative 5J. And then red will be my constant, which is just that one. So now I need to add together my 4.2J, my 6.7J, and my negative 5J. So I'm going to do my same signs first. So I'm going to do 4.2 plus 6.7. That gives me 10.9. Then I have positive 10.9 and negative 5, so those are going to subtract. So I've got 9, regroup, 5.9. So I have 5.9J, and it is positive because our positive 10.9 was more than the negative 5. And then the negative 5, the constant, our red, doesn't have anything else to combine with it, so we just keep it the same by itself. When there's nothing to combine with it, you just bring it down, keep it the same. So now for this next one, we'll do shapes. So our first shape, we'll just put a square around C. So then any C's, we're going to put a square around. So I've got 10C. Now I've got D, I'll put a circle around that, keeping the plus with it and keeping the minus with this one. So then I want to put my squares together. So 20 plus 10 is 30C. 8, positive 8 and negative 5 are different signs. When we add different signs, we subtract. 8 minus 5 is 3. Our 8 is further from 0. We have more positive than negative. So it's going to be plus 3D. So that's how we combine our like terms. Another thing we'll run into is problems where they say, use an expression to find the perimeter. So we need to remember that the perimeter means that we're adding all the sides up. Adding all the sides. And if they only give us 2 sides, like in this one, remember this 7.5, this up and down here, that's the same as this across. So this one is also 7.5. Same thing with this 12y. This whole length here is the same as this side here. So this side is 12y. So if I go around my square, I'm going to write, I've got 7.5 plus 12y plus 7.5 on the other side, and then 12y on the bottom. So then I am simplifying it. When they say simplify, that means we're combining our like terms together. So that's going to be my constant 7.5 and positive 7.5. Then I've got y here and y here. Those are both positives. We want to write our variables first. So 12y plus 12y is 20. Oops, that's a highlighter. 24y. 7.5 plus 7.5 is 15. So our answer is 24y plus 15. So that's just something to remember. Whenever we're doing perimeter, that means we're adding all the sides. So all 4 sides, or however many sides the shape has, you're adding them around. And then parallel sides like this are going to be the same length. So then we're just going around the shape to put all the sides and then combining those together to get our final answer here. So to summarize, so first we want to identify our like terms. We can do that with color coding or with shapes. I like color coding more, but we don't always have colors, so you can do shapes. Then once we've identified all of our like terms, we're going to add or subtract those like terms together using our plus and the minus in the expression to know if it's positive or negative. Remember, the plus means positive, a subtraction in front of it means it's negative. Then we're putting our answers in alphabetical order, which I touched on a little bit before. So if I have like x, b, and then 2y, we'll call it 3x. 3x plus b plus 2y, I'm going to rewrite this so that b is first, then 3x, and then 2y, because B comes first in the alphabet, then X comes next, and then Y comes last. And then if we have different exponents, you put them in exponent order too. So you would go no exponents, then exponent 2, then exponent 3 after that, and you just kind of go in order. And that is how we combine like terms. That's all there is to it.